Welcome to those of you who are here because you suffer from imposter syndrome. Welcome to those who don't, but want to be more helpful colleagues. And welcome to those of you who came here to tell me my presentation is rubbish and I have no business being up on this stage. I know you're here. My imposter syndrome told me so. So first of all, the sponsored ad. We're hiring at Nord Security, not just Android devs, of course. Do take a look at the roles we have. We have a stall outside in the exhibition hall where you can meet my colleagues and ask for more. And if you listen to my talk today and think, you know, working with that guy won't be that dreadful, do throw your CV over and our wonderful recruitment team will be in touch. So my name is Chris Ward. I'm the Android engineering manager for NordVPN at Nord Security. I'm not sure why I always keep this slide in my deck, but my email is there if you have any questions but can't get hold of me afterwards or don't particularly feel like asking them here. And that's my handle if you want to throw any abuse at me on Twitter. So those of you who are more experienced in coroutines or concurrency will have moments during this talk where your mind will go, well, not in all cases, or, well, not quite, or not exactly. And I ask you to remind yourselves that because you've managed to take in quite a lot of knowledge over the years already, that you might feel that this nuance in your head is important. But in reality, on a topic as complex as this, for others who are learning, it overloads. So my analogies will be simplifications, sometimes oversimplifications, that don't always fit into a nice ribbon-packed generalization. And that's needed. But what I hope they don't do, and the reason I pick these particular analogies, is oversimplify to the extent it leads people down a path of complete misunderstanding. In fact, lightweight threads did that for me with coroutines because, well, they're really not. They manage threads. And while the term lightweight threads helped me to understand one of the main benefits of using coroutines, it had a later effect of having me entirely misunderstand how they hang together. So I hope my analogies don't do that, but as always, this is a new talk, so I'm really excited to hear feedback from those of you who are still learning. So why am I here talking about concurrency, but from the context of imposter syndrome? Those of you who know me or have been to any of my talks know I talk a lot about my late ADHD diagnosis and the challenges in software development I had that came before it. And I figured that I'd already exposed pretty much every single one of my vulnerabilities, so screw it, what's one more? But the reason I wanted to talk about this topic specifically is this. I've always struggled with what I'll call, for the sake of this talk, concurrency. And I'll explain my use of terms a little later, but it's also one of those topics nobody really wants to admit they don't get. Anyway, a while ago, after I got my diagnosis and my medication, I said to myself, Chris, it's time for you to knuckle down and finally get this topic, properly learn coroutines. You don't have an excuse anymore. You literally have morning amphetamines. So I spent a good bit of time finally nailing this down, and when I did sort of nail it down, I told everybody, one of my previous teams in my morning stand-up, and I just said, you know, I didn't really get this, coroutines, but I spent a bit of time on it, and you know, now I do. And then what happened is someone more senior than me piped up and said, yeah, I don't really get it all either. Could you maybe give us an explainer or something? And then slowly the dominoes sort of fell down, and you would sort of realize, I thought I was the only one, but no, the rest of the team had problems as well. And that was a great team. Nobody was judged for their knowledge or lack of, and we looked after each other. And that's sadly a rarity in my experience in software development, but even in that safe space, concurrency was one of those things where nobody dares admit it's actually something they still don't fully get, or at least feel they don't get. And the worst thing about it is that you can largely get by with knowing the basics, but you spend the entire time thinking that because you only know the basics, that you're one merge request or production incident away from everybody thinking you're a failure. So this talk is here to, first of all, give everyone a kick up the backside to remind them that actually they can probably do this. But also to remind those of you who are over that mountain, please be honest with your team members about how difficult you found it. It will do them a far better service in the long run to make them realize that the people they look up to found it hard as well. And they'll realize that it's not that they're bad at this, because they'll start to have a confidence to start asking you, and asking you what they may previously have worried are stupid questions, and you'll be able to help them fill that knowledge gap far quicker than if they just kept silent. So now let's get to the meat of this, which is to try and explain the basics of concurrency in Android, the problems it solves and the problems it creates in as minimal detail as possible so that you have the most basic of understandings without being overwhelmed by too much information. And I include terms in that too much information. So when starting somebody off on concurrency in Android, they don't need to be told the difference between concurrency and parallelism. They don't need to understand loopers and handlers. It's not going to have any bearing on what they do for the time being. A complex topic also has oversimplifications, and in the learning of it, some omissions as well. So I'm hoping the ones I pick don't lead people on a path of misunderstanding, but please feedback if they do. And actually, I think this quote is a tiny bit dry, so let me simplify it further. So that's what we're talking about here. You just need to make your code multitask. Easy, right? I can't even make myself multitask. So what I'm going to try and do is explain the bare minimum you need to know to get going. So, I'll explain why we make our code multitask on Android, and frankly, in any other UI-based app development world. I'll give you the smallest overview of the problems that concurrency itself introduces, because it may be a fix, but it also creates other problems itself, and some of the things that you've been unknowingly using to deal with these problems. And then I'm going to give you the minimum you need to get started on coroutines with minimal scope for cocking up. I'll then show you a few tips and maybe sort of give you some resources to expand your knowledge, so stuff that's helped me. So let's go. So let's start with a why. You know that you should use concurrency in Android, but what are the reasons? The short and really oversimplified answer that you've almost certainly been told is to keep your UI smooth. But why does concurrency achieve that? And in order to answer that, let's learn a little about threads. So what is a thread? There are lots of analogies given to explain it, but I really like to think of it as a train track that your code runs on. And I like this analogy because it works so well with threads in terms of what they are, but also their limitations. Your Android apps all run on the main or UI thread, commonly referred to as the foreground. And it's called the UI thread because it literally runs the UI. And if something is on that train track, if one of your code trains grinds to a halt because it's waiting for a task to complete, then every train behind it is stuck too. And the UI trains are really important. They're your UI redraws that have to happen a certain amount of times every second. They're the button presses or scrolling of a list that your user is performing. And it takes just one train to block all those other trains, and your user will notice. And if they're blocked for too long, Android gives them the ability to kill your app, the dreaded ANR, or app not responding. In fact, if you even try to run a network call on the main thread, Android tells you off. So in the simplest explanation of how we use threads, when our UI thread wants to do something that may take some time, something that's CPU intensive, or something that has a wait involved, such as a network call, we throw that task to a background thread to process it so that our UI thread remains as clear as possible. And when that task is finished, the result, if there is any, returns to the foreground thread, and you do whatever it is you need to do with it. Oh yeah, sorry. I learned how to do animations in Keynote. This took a full hour, but it was worth it. Thank you. So, have you ever been this guy? So many libraries and ways of doing things, and depending on the job ad you're looking at, you're expected to be an expert in at least one or two of them. So, here's a secret. You don't need to know all of this. These libraries were not developed to make things harder or to add to your work list. They were developed to handle many of the problems that arise from using concurrency. But because concurrency is hard, they occasionally approach the same things from different angles. And because there are lots of these libraries and approaches, it feels mountainous. RxJava isn't really an asynchrony library. That's sort of just one tool in the RxJava Swiss Army knife. Its power actually lies in its reactive functions that act on data. But because it did things far easier than async tasks, Rx became something we all copied and pasted, even for the simplest of API calls. We were using a sledgehammer to crack a nut. Second secret, you can use any one of these to achieve something good for most cases. Oh, wait. You can use any one of these to achieve something good for most cases. Deprecated normally means stable and tested in Android, but async task was a monstrosity for my neurodivergent brain, and I'm frankly glad it's gone. So this is a problem with something like concurrency, because there's no one way of solving it. And because it's so complex, with multiple facets, it's subject to opinions. And some developers aren't particularly great at separating their own deep personal preferences from fact. However, it's fair to say that some tools are better at dealing with certain things and situations than others, and certain libraries may be better, but less good at dealing with other situations. One of my former tech leads always told me that it didn't matter if a cat was black or white, so long as it catches mice. And I like that phrase, but also we live in the real world, and you might want to be employed. So if I were to recommend learning anything, I'd probably go with coroutines and RxJava to cover most scenarios, and maybe spend some time understanding the thread class a little. But given a preference, I won't explain just why just yet, I'd go with coroutines. So let's look at the absolute bare minimum you need to write to throw a task to the background. Gosh, that's really simple, isn't it? And you can see in the print statements below which thread each one is being called from. Although, just as an aside, I don't know if this has changed since. I've been a manager for months now. I haven't actually looked. But don't use print statements to debug threads normally. I won't explain why. This is just here to print out the thread name. If you need to throw something to the background, you put it within those curly braces and whatever. Learn about the rest later. So that's everything. You mastered coroutines. Thanks for coming to my talk. Bye. No, please. Coroutines, like other libraries, seek not only to make it easy for you to do tasks asynchronously, but also to help address common problems that arise when doing so. So to understand one of these problems, let's return to our track analogy. Here's our UI thread in track form. And you can tell it's the UI thread because it's pretty. Not a single pixel out of place. And it's clear there are no broken down trains in the way. Now, threads might seem like a magic solution. Got a long task to do? Create a thread, throw it there. Got lots of tasks? Why not multiple threads? Sure. But like train tracks, laying down an entirely new train track has a cost to it, and you don't have limitless space into which to lay these tracks down. And in the literal programming world, you'll find that if you create threads with reckless abandon, you'll pay for it later. So what you ideally want is an optimum number of threads, or train tracks, but also some form of manager to deal with the tasks and place them on the right track at the right time to ensure maximum use of track and minimal blockage. You need, oh, no, not that dreadful Tory, go away. You need the coroutine octopus. Well, 1 second, hang on. Nearly forgot the prop. I really should stress that this talk isn't sponsored by GitHub. So I like octopuses, and before the same pedants who came here to tell me there's a difference between concurrency and asynchrony decide to pipe up, both octopuses and octopi are acceptable plurals. But I chose an octopus to explain how coroutines work with threads for a couple of reasons. One of them is there is absolutely no way you're ever going to forget the coroutine octopus. You can try, but you won't. And that will hopefully help you remember the analogy. And the second is what coroutines do. So let's finally explore coroutines with octopuses, or octopi. We're returning to our set of train track threads with train chunks of code on them and a massive octopus overseeing the entire thing. Remember what happens when a thread is blocked, when a train is stopped or slowed down on our track? No other train behind it can move either. Now I want you to imagine this giant octopus with its legs, and yes, they have legs, not tentacles, diligently lifting up those stopped trains so the threads aren't blocked. Or, as one might say, suspending those blocked trains. Then when your code's finished doing the blocking thing, the octopus returns it to a track. May not be the same track, but it will be in the group of tracks you wanted it to be in. You don't need to worry about what tracks because you outsource that concern to the coroutines library, to the octopus. So what does it mean to suspend? Normally, I'd say this is too much detail to go into, and I'm trying not to overload you with information, but I really struggled with the concept of suspension, and I found that sort of really just scratching the surface a bit helped me with a few things. So the first point on this slide, you don't need to understand all this if you're beginning. If you've turned up as a beginner today and you're now lost, just forget this. You know, if you want, you can just walk out now with that previous coroutine boilerplate and do your own discovery. But I think this is helpful. So on a thread, blocking calls block the thread. We know this. And when a thread is blocked, code waiting behind it to be executed isn't being executed. And when a coroutine reaches a blocking call, however, it's suspended and other tasks can be run. And this is because under the hood, your task inside your coroutine is compiled into a simple state machine. And when this octopus is lifting the train off the tracks, what's really happening is that the code inside your coroutine is just not being run because for simplicity's sake, if statement checking its suspension state evaluates to false, and the flow of execution just moves to other tasks. Nothing is real, the cake is a lie, the ghost is the janitor in a mask, and a coroutine is just an if statement. Now, of course, this is just a gross oversimplification, but not by much, and I only put this in here to remind you, especially if you suffer from imposter syndrome, that none of this is magic. It's code written by people who, when they were at your stage in their career, had as much self-doubt and who saw the mountain ahead of them to climb as utterly insurmountable. So now we get the basics, we just need to cover the very common problems that multi-threading introduces. And a number of these are already fixed by current Android practices, or at least partially fixed. So hopefully this will help you understand why these practices are so important. And I know this might seem like a lot, but try and bear with it. And if you don't get it, message me and tell me afterwards, because I really, really want to get this right. The first is something you'll all have heard, which is the concept of thread safety. And it's simple when you think about it. If a series of threads all have access to a shared changeable resource, like a variable, then there's a risk one might read it, change it, and assign the changed value back to that variable, but in the meantime, another thread may have changed it, and that change is now overwritten, just as an example. And if you try and change lists from multiple threads at the same time in Android, you'll see that infamous concurrent modification exception. So people often think, at least I did anyway when I first started, there's this magic definition for something that's thread safe. But actually, we just really have a bunch of ways to make something thread safe. So let's breeze over a few. Oh, sorry, I missed first time running it. So yeah, these are all the bits I was sort of talking about. Where are we? Hang on. Ooh. Yeah, sorry, give me 2 seconds. This has never happened before. Okay, I'm going to go back. What on earth? Okay, let's just stick here. I covered this bit. Okay, right. So yeah, right, let's do this one. So here's another one that's sort of thick. Did you get the last slide, by the way, or did I skip that? I've lost my thread, ironically. Are we all good? This previous one. I don't understand what's happening. 1 second, okay. Yeah, I think we've done this one. I think we've covered this one, I think. No, I haven't. No, my apologies. Yes, so thank you very much. I'm so sorry. Right. So actually, using immutable variables was actually something I really struggled to get, and I think it was just the way my mind works, because my answer was always, sometimes you need to change variables. That's why they're called variables. So how does making them unchangeable help? So I hope this wording here is a tiny bit easier to understand. Use immutable variables until you realize you need to change something, and then when you do, ensure that variable can only be changed in as controlled a manner as possible. So in your view model, you may have a mutable property that can only change in that view model, but you expose that property as read-only publicly. In fact, a lot of multi-threading problems are solved just by saying reduce the circumstances by which this thing can be changed. And a very common way of doing that is by funneling all requested changes to something via one place. In fact, in modern Android development, I'd even go as far to say this is a favored way of doing things. If we take all these multiple tasks running in one place and force them through a funnel into some sort of queue on one single thread, we obviously reduce the risk of these sorts of collisions. And this second point, I've included it for completeness, but I didn't want to sort of go into too much detail because this, going into discussions about deadlocks and stuff is far beyond the scope of this talk, and it's a very difficult topic to sort of cover in, to do it justice. But, you know, there are other ways of ensuring that a shared resource is not accessed at the exact same time, but my personal view is that these should really be the exceptions and not the rule in modern Android development. So if you have a resource that is directly changeable from multiple places, ask whether this is the best way to do this. In most cases, it probably won't be. There we go, now I'm in the right one. So here's another that is, for most cases, fixed by coroutines on Android, but it sort of feels like we need to cover it. So tasks on another thread runs completion, and sometimes, of course, they never complete. And even if the calling class ceases to be in use, the task on that thread continues. You can, of course, interrupt that thread, and so long as the code you've thrown to that thread responds in a timely manner or responds at all to that interruption, that's how we would mitigate it. And there are obvious practices that help in general. Obviously, the shorter your task, the quicker it will end. But with coroutines, you get a couple of nice features that help you along the way. So first of all, let's go back to our really basic coroutine example earlier. This is what we call coroutine scope. Now, if you're like me, you'll forget what this is called over and over again, and always have to remind yourself, especially when there are other terms to confuse it with, looking at coroutine context. So don't beat yourself up for this. By launching the coroutine from the scope, if the view model ceases to exist, the coroutine will be marked for cancellation and will automatically be cancelled the next time it's suspended. When you start writing more complex coroutines, you may need to start managing that process yourself to an extent and keeping an eye out for when it's been cancelled. But once again, we won't go too far today, but by the time you've reached that stage, hopefully you'll be ready for it anyway. So too long didn't read. Coroutines are designed so for most common cases, a number of considerations are handled for you. Now, I normally try to not put too much text on slides, but I thought I'd put this here. Yeah, thanks, Keynote. The animations were worth it. I thought I'd put this here because it sort of, for me, it served like a very basic cheat sheet, especially if you find you commonly confuse terms or forget them. So feel free to take a photo of this if it helps, but I will make sure the slides are available online afterwards. So let's quickly just go through them. In order to run, a coroutine needs a scope, and that's the space in which it runs. So I always start with remembering scope, because I always confuse scope and context, which is the next one. Because in the traditional Android world, you refer to the context to explain the space in which something exists, whereas here it's the scope. So once I've got the scope, I remember that the context is everything else. That's why I remember it. Maybe it works for you, I don't know. So the context is the coroutine's name, the reference to its job, everything else that describes that coroutine is in its context. So once you remember the scope being effectively the lifeline or environment, everything else is the context. That's how I remember. So in order to use coroutines, we need to be in the coroutine world. And that means we need to launch from the normal world to the coroutine world. And finally, there's the dispatcher, which is technically part of the context as well, but because you often specify it seemingly separately, I thought it should deserve a special mention. And to remember dispatcher, once again, I use first letters. It defines the destination thread type that the coroutine will run on. And because visuals often help, here it is all defined in that basic coroutine. And look, there are other ways of launching coroutines. There are lots of other things you can do. You can change the thread type the coroutine's running on. But for simplicity, this is a fairly good starting reference. Your scope, what I like to think is the scope of the coroutine's life. The scope of the environment that the coroutine's running in, the life of the environment. Your launcher, so what brings you from the ordinary code world to coroutine world, where you can call other suspend functions. And the destination thread type here. You're saying that you want it to be executed in the thread pool here, so optimized for I/O-intensive operations, so network calls, file I/O, etc. Oh, yeah. Damn. OK, Right, so one of the things I've always struggled with modern software development is there isn't always a clearly defined path to learning, because things change. Some things may be more important than others depending on the situation you happen to be working in, and of course, because there's just so much out there for you to be able to learn everything. So for further learning, these are the things that really helped me. Oh, hang on, as we go back. So if you want to sort of take these down. So programming Android with Kotlin. This is an amazing book. Really, really, really recommend it. And actually, one of the authors gave a talk earlier today on memory leaks. So do check that out if you missed it or when the videos go up. I'm a really big fan of this book. It's sort of, how do I put it? I mean, it's accessible. It was easy to read. It doesn't sort of give you more than you need to know, but it still manages to go into such depth. So Amanda, one of the authors, if you're in the audience, please say hi to me later because I want to thank you. And then the second book, I really recommend chapter 6, which just goes over coroutines in examples, and it covers terms and it covers deadlocks a bit, which I haven't gone into here. Now, I know you can't click the links here, so I'll tweet these later and make my slides available, but also I can see people taking photos, so do feel free. These two blog posts go into quite some detail about the state machine the compiler turns your coroutine into, how it all hangs together. If you're interested in the mechanics and you want to learn more than my very sweeping generalization of it being an if statement, these are really, really good explainers. And reference pages that I find really useful, sometimes even to read end to end. First one, really do have a look at, and I know it sort of seems dry, and I'm sure you think to yourself, oh, I know how to debug my app. But actually, when I sort of read through it, I learned a few things I didn't know, particularly if you've sort of struggled debugging threads. There's some important tips here, especially on breakpoints. A second is for just a bit more on mutability and its importance for thread safety, and I've only slightly touched on that, but can't dig as deep, so do have a look. And the final one really sort of helped me understand the application. And in fact, I'd recommend this to every Android developer, sort of understand the application of coroutines in the Android sphere and where certain things are best to go and why. So finally, some tips. If you're learning, the biggest bit of advice I'd give you is not to be afraid to ask. Your team is there to help you, and if they're not, and they don't, please speak to me afterwards, and I'll introduce you to our Nord security recruiters so we can mainly find you a better team. To leads and seniors, be open about offering help for complex topics. Go beyond just comments on merge requests. And it's so important not to get frustrated. Learning why someone doesn't understand your explanations is a learning process for you too. It makes you a better mentor. And finally, whether you're neurodivergent or not, repetition, repetition, repetition. Repetition. So thank you very much for coming, and I hope you have a really great DroidCon.